Hello 8th graders, this is an IXL support video. Specifically, we're going to be helping you with I4, and I4 is called Find the Constant of Proportionality from a Graph. So our big key here, we're going to have to understand what a constant of proportionality means. That's just a fancy term to mean the constant ratio that you see in all these proportional graphs or tables. So if it's proportional whenever I do y divided by x for any data point on the graph or the table, I should keep getting the same ratio. And whatever that constant ratio is, that's what we call our constant of proportionality. The ratio will also represent our constant rate of change. It'll really describe how the thing changes over time. It's an important number to understand for these things. And in our first example here, we always want to pay attention to the y-axis and the x-axis and what the word problem tells us about those. And here we are told in the second sentence that there is a proportional relationship between the number of plates Cooper makes, which is x, so x-axis measures the number of plates, and the amount of clay that he uses in pounds, which is represented by y. So to find, we know this is a proportional graph, it's a straight line, it goes through the origin, so to figure out what the constant of proportionality is, the main question here, we're going to need a data point or two from the graph. So we're going to mark two data points on this graph. We're going to put a point right here, and then we're also going to go ahead, make that a little bit bigger. So you see in blue there 1 point, and then up here later on we're going to mark another data point. Both of them on that line, right on the corner of a grid box, easy to pick out. So here, this first data point we could say has the coordinates 1 for x and 2 for y. It lines up with 1 for x, and I'm going to add some detail, that means 1 plate. And it lines up with 2 for y, which really means 2 pounds of clay. So that's what I mean by 1 and 2 there. It really tells me 1 plate will use up 2 pounds of clay. So to find that constant ratio, I can just put that into the table. 2 pounds for every 1 plate. And what we should also see if we pick other data points later on, like this point right here, this data point tells us we have 8 pounds of clay, right? The y value here is 8 pounds. And to get those 8 pounds of clay used up, that was because we made 4 plates. So the x value, y over x, would be 4 plates. And here, ultimately, if we did 8 pounds divided by 4 plates, then we would end up getting the same ratio. We would get 2 pounds for every 1 plate, like we had down here. So that's our constant ratio. No matter what we pick out, all these points, when we do y divided by x, it's going to simplify down to be the ratio 2 over 1 at the end of the day. 8 divided by 4 is the same thing as 2 pounds for every 1 plate. So that's our constant for this first answer here. We're going to keep going looking at another graph, but again, we're going to skip forward to make it a bit more difficult. The big key here is always just going to be to figure out where are data points that are on this graph, and that'll help me find the constant of proportionality. So some of them get a little bit more difficult. You'll see, for example, this says business is booming for Larry's house cleaning services, and he needs to hire more house cleaners, and then the graph shows the relationship between the number of house cleaners Larry hires and the number of houses his company can clean. We see for this line here, the first thing they ask us, do x and y have a proportional relationship? And you could pick out data points, but once it doesn't start at the origin, that tells us it's probably not going to be a proportional relationship. Or in fact, it can't be. We can pick out the data to prove that. This first data point, maybe, let's go ahead and show you a bit. Our first data point that we could pick out probably lies right here. We could go with the data point 5 house cleaners for 30 total houses that are added. So that would be 5 and 30 houses. And if we pick another data point later on, maybe we choose this one right here that lines up with 10 and 45. We'll switch colors for that, put that into green. So this one here is 10 and 45. And if I ultimately try to do 30 divided by 5, 30 divided by 5 is going to give me just 6. Let's show that out here quickly. If I do 30 divided by 5, that gives me a ratio of 6 to 1. And this is a straight line, but because it doesn't start at the origin, this next ratio is going to be something different. I'm going to be doing 45 over 10. So if I do 45 divided by 10, I know whenever I divide by 10, I'm just going to move the decimal point one place to the left. So this becomes a ratio of 4.5, or 4.5 over 1, which is not the same ratio as 6 over 1. You're saying, yeah, Mr. Doherty, that's a mess. We'll fix that. Here's a better 6. So 30 over 5 gives us 6 over 1. We see because this straight line didn't start at the origin, the data points for y and x won't maintain the same ratio to each other. They don't start out together at 0 and 0. So this is something that's an example of something that's not a proportional relationship. And now we do get one that we should see from the characteristics or qualities of the graph. This must be proportional because this is a straight line that starts at the origin. So they asked, does this have a proportional relationship? I'm going to go ahead and just say yes, that it does. I believe at this point that anything's a straight line that starts at the origin is a constant ratio, and we're about to see why. In this case, we're looking at oranges as measured on the x-axis, so I'm going to change my x-axis here to oranges. And on the y-axis, we're measuring the ounces. So Maria's squeezing some oranges, and we're measuring how many ounces of orange juice she gets out of those. So we'll call that ounces of juice. And we don't know yet. So if I go ahead and pick out a point on this graph, I'm going to look for data points that are right on the corner of grid boxes. And the first one that we'll put here in blue is right here. And we're going to label that data point. The x value is 5 oranges. And at this point, when we have 5 oranges, they give us 10 ounces of juice. I'm going to just call that 5 oranges leads to 10 ounces. And when I do y over x here, I'm always going to have to do the y over x to get my constant ratio. So we're going to be using 10 ounces of orange juice divided by 5 oranges. And we know that 10 divided by 5, that will simplify to give us, give me 1 second there, 10 divided by 5 should simplify to give us 2 over 1. 10 divided by 5 gives us 2 ounces of juice for every 1 orange. And you'd find that at other data points. For example, we'll switch the color over to green. If I had picked this data point right here, at this data point we have 20 oranges right there, and it lines up with 40 ounces. 20 oranges, 40 ounces. And 40 divided by 20 would give us that same 2 ounces for every 1 orange. That leads to this constant ratio. So that's the idea of this assignment. Figure out if the graph's proportional or not. All the ones that start at the origin and have a straight line are proportional. And once you know it's proportional, just use any data point on the graph. Y divided by x should always give you the same constant ratio.